Hello, everyone. Welcome to this session. Thanks for your presence here. My name is Ajit Dulaj, and I'm from Morgan Stanley. I work as a database platform engineer at the Enterprise Technology Group at Morgan Stanley. And most of you know, those who don't know, Morgan Stanley, we are one of the, global leader in investment banking and financial services. Our technology stack, especially the database stack, has most major vendors and their products. And our mindset is this, actually, is modernization. So how do we do that? We use self-service tooling for, and automation to actually accomplish this modernization. And modernization is actually ingrained in our DNA. So we always, make sure the most modern technologies are incorporated into our stack. Snowflake at Morgan Stanley, we have a sizable number of production applications now have migrated to Snowflake. They're from various different categories, and some of them are listed here. The data sharing, data analytics and reportings, historical archives, just to name a few. So the primary driving factor, I think, is, the unique out-of-the-box features that the Snowflake provides. And the teams were able to leverage these features, to kind of streamline their workflows and business process. Now, for instance, for data sharing, we have, applications that are using traditional file-based data sharing for a client. So they're now using the secure data sharing feature of the Snowflake to accomplish the same thing. So, that's what we are doing with Snowflake. So the footprint is kind of growing. Now, our database platform, if you look at as a service, is kind of centrally managed, unlike many organizations, right? So, and also centrally managed globally. So this allows us to put very rigid control boundaries around all these, applications, and it enforces that control boundaries universally to all our applications that are our internal clients. Now, this enforcement, when I say enforcement, we are enforcing technology risk guidelines. We are enforcing data security guardrails. We are also enforcing access management policies. These services are built using different technology or functional units. And each function unit has its own engineering and support teams. And they provide this function. So there is actually, if you look at the whole thing, we are actually kind of stacking all these functions into, one big service. So this is actually our Snowflake database as a service, model. So if you look at it, our enterprise service layer for Snowflake centrally manages all the Snowflake accounts. And all the application access are also managed through, that service layer. I have listed a couple of, technology or service units here. Client engagement team, for instance, they actually, act as a liaison between our internal Snowflake users and the Morgan Stanley, it's a Snowflake product. So all the support and all the, performance and all the other calls actually go through this client engagement team to Snowflake. So they kind of controls that. Enterprise change management, for instance, they actually captures all the changes. Whatever happens in Snowflake is captured, and they are actually used for auditing and reporting. So that's a function of change management. Public cloud infrastructure service actually manages all the cloud infrastructure. And, for Snowflake, and, we have Azure, AWS, all that is managed by them. So the central team here, as you see, is Snowflake self-service. So Snowflake self-service tool is being used by other technology functions as well. And, so this is the key component of our service layer. All Snowflake interactions, except for connections from applications for DML type activity, will be routed to the self-service layer. They have no other way around it. No applications can bypass this control. So this actually gives us a rigid control around all the applications. It completely encircles everything that happens in Morgan Stanley. So let's move on. So if you think of many organizations, they look at Snowflake as a self-service endpoint, SaaS endpoint, And there are private and public, connection endpoint URLs they used to get to that. There are a collection of warehouses, databases, and other objects that are there. And they use multiple permission schemes to manage access to these resources. And, that's how they kind of manage the industrial. But we have to, our requirements are different. That's because what we are doing is we are offering a database as a platform using Snowflake to our end users and customers. So what we have to do is, as a platform, there are some expectations and we have to live up to that. And some of the major expectations are performance, reduced cost transparency, and high availability. This is a key requirement in Morgan Stanley. All production applications must have high availability. So our platform as a service offers all these features. Now, so in order to accomplish this, what we have done is take a single Snowflake account. We have created what we call as logical or virtual units within a Snowflake account. The primary building blocks of these virtual units are nothing but Snowflake roles and permissions. So these logical units, there can be many logical units within a Snowflake account. Now, in order to, we also have to build additional service layers outside of Snowflake to create such virtual units. So there are many such layers, but I'm just going to what's relevant here is a metadata layer. So metadata layer is a service layer that actually uses a on-prem Postgres as its data store for obvious reasons, right? We don't want to actually put all the eggs in the same basket. And it also manages Snowflake access, account, network, and session settings. Everything is managed through this metadata layer. So anything you have to do at the Snowflake account, they will have to go through the metadata layer. That's one thing. Now, the other thing I want to show, so if you look at the real advantages of treating a single Snowflake account as this logical or virtual unit, is that from an administration standpoint, operational support, governance, Snowflake feature, if you look at our back as a feature or any feature for that matter, is all managed at this logical unit level. So I'm going to go through the logical unit so you will get a clear idea what I mean by logical units and how I implemented it. The other advantage is that, operating costs, right? So speaking of operating costs or reducing operating costs, these logical units are allowed to share warehouses, obviously the compute, that's the most cost-consuming part. They're allowed to share those resources while staying within the security perimeters that we have defined at the control level. So the logical units have its own security boundary, but some resources like warehouse can be shared for optimization reasons. Application high availability. So failovers are also implemented at this logical level. So, and I have this is one of the favorite topics. So I have a full session on how we implement high availability at the logical unit level. As we go along, you will see that. So, there are some other features, and we have implemented one-click failover. So this logical partitioning of this account helps us, manage all these applications at, at the logical level. All right, so let's so what we're calling this, we have to coin some term for this logical partitioning, and we call it application multi-tenancy. So if you really think about, so just to give you an idea, what is shown in this green boundary is a Snowflake account. We have multiple Snowflake accounts, many Snowflake accounts, but they are application environmentally allied with the application environment. For when we create production application environment, what we do is we actually use two Snowflake accounts. They are from two distinct regions. Our service layers, we have service layers that actually virtually pair them as primary and secondary. So these virtual pairs and the logical units are actually deployed in these virtual pairs. And then if you look at the blue, what is depicted by the blue dotted boundary is a logical unit. And there's some attributes that I'm showing here. one of the key attributes is a unique application ID. So this application ID kind of maps that definition or the metadata of the logical unit into our metadata layer. So all our metadata and other external layers knows this logic unit based on its definition. There's another attribute worth mentioning is we call it regionless URL for obvious reasons because, as I said, we pair them. So the regionless URL, I think the Snowflake terminology is a client redirect URL. So each logical unit gets its own client redirect URL that can be used by, the applications living within the logical unit to get to that. So when we deploy these logical units, there can be hundreds of such logical units per pair. So in the application onboarding process, so it's actually part of a service pipeline. So it initiates like that. Applications wanting to access Snowflake initiates a request using our service layers pipeline. It gets approved by, the relevant stakeholders. And once that is onboarded, that's get assigned to, it's kind of put into this one of these logical units that's pre-created. So that's why actually I'm calling it application. And I'm using I'm intentionally using some names like App 1, App 2, so you will see why. And as I'm actually going through there is an illustration slide that, you will be able to relate to that. So when the application, then obviously every application has to have some resources like databases and, whatnot, right? So they're all living within this logical unit. Again, remember, so I hope I'm actually trying to convey the image of how you can visualize a single Snowflake account and, these virtual units sitting here and there. But from a Snowflake standpoint, there are warehouses, there are databases, there are permissions, all that, right? So that's how, most organizations look at it. But because we have that additional layers that we create on top of it, we get a different view of that Snowflake account. So we go through this layer and we see logical partitions all around. We see what is assigned to these logical partitions, how features are assigned to these logical partitions, and that's how we manage them. So warehouses, right? So we talked about one of the key feature of a database platform as a service for Snowflake is cost reduction. So the way we do that is we pre-create a pool of warehouses of different sizes. From our experience over, many years, we have actually come up with the standard sizes what most applications will benefit from. We go from extra small, to large. And this pool, as I mentioned earlier, the logical units are sharing that. So when applications are onboarded to this logical unit, applications get to share the warehouses. So there is a control mechanism by which they are granted access. This is actually all done through, the service layer I talked about. So once applications, choose which warehouse, obviously, the permissions are granted to that application for, accessing the warehouse, and now application can use these warehouses. But remember, so there is actually, what's happening here is there is a warehouse compute share happening. Because applications are thinking that, we are within this logical unit, they don't really know who else is accessing that warehouse. Because, because of the concept of logical partition, they don't know anything else that's happening inside the Snowflake account. Just like how we see it, that's exactly how applications see it. For them, they connect to Snowflake, they do whatever they can do with Snowflake. They think of the whole account as theirs, but really not. So that's what I'm, trying to convey. What else is worth mentioning? This is how we created, multi-tenancy. So one of the things actually worth mentioning is I touched on high availability, which is a key requirement, right? So a logical unit also can have a high availability strategy. So we assign a high availability strategy at the logical unit level. We support two distinct kinds of high availability strategy. One is replication, and this replication strategy is built using Snowflake's own replication feature. And I'll come to that in a second. There's another one that actually we use, which is also interesting, and this is actually done using our custom service layers, and we call it dual ETL. So the dual ETL feature is, in other words, you can think of it as application data mirroring. So we do all the facilitation. We actually give them the ability to actually, mirror the data But the data management is purely application's responsibility. Then nothing happens under the covers. Whereas in a DR strategy, if you place your application in a logical unit that has the replication as a strategy, they don't have to worry about everything. Everything is actually done through the replication pipeline, using Snowflake. So it actually happens automatically. So applications can have many databases. They're all in the same account, but it's kind of the affinity, our metadata definition of that with it's actually to this logical partition. Snowflake. So before Snowflake came up with this cool feature, we had to custom implement the high availability feature of our logical unit. So we were using, the database replication feature that was available then, with additional service components or whatever to accomplish that, right? So we had this design from a while ago, but they have recently introduced, actually GA'd. It was there. They recently GA'd a feature called account level replication. So that gave us, so we kind of refactored. So that gave us another more optimized orchestration of how our replication works. Now, without going into the feature, I don't know if you guys are familiar with the replication, account level replication feature. Without going into the details of it, very high level, it actually has these components called replication groups and failover groups. So what I'm showing here is how we use those components in our design. So if you look at, again, the account layout, so we create one replication group per account. And in that replication group, we capture account settings, network policies, roles, users, and permissions. And that's one per account. Whereas when it comes to failover group, we create multiple failover groups, one per logical unit that has opted for DR as its strategy. So we have many such, failover groups sitting there. And the failover groups include databases and shares and other resource that belongs to the application that's been onboarded to that logical unit. So if you think of, from a Snowflake account level, if you look at it, there are hundreds of failover groups sitting there. And, failover groups have a collection of databases, shares, and other objects. We support all the objects that is supported by the feature. So the shares are there. There are some limitations that they're working on. We'll cover that in one of the next slides. So there's another requirement actually. It's not as straightforward as you think it is, right? So when you do these failover groups, now you can think of these failover groups, logical units, and applications are all sitting in this boundary, interacting to each other. But there are certain cases where applications may want to actually move these objects or replicate these objects as transactional units or replication units. So we facilitate that using our self-service layer by allowing them to group or regroup their resources within this failover group. That's another service that we, has implemented. So from an application standpoint, they'll say, oh, I'm actually working with this other application, and, there are certain databases that we want to actually move together because, they may be cross-referencing, tables or views, which may, if you don't do that, may create a problem called dangling reference. I don't know if you're familiar with that. So using this strategy, they are now able to, because they are working together, they're now able to move these objects into a single failover group, and then both applications will be able to do it. So that's another feature that we have implemented. Warehousing, right? Oh, they are standard pools. So let's say in the account, when we create the account, we create a pool. Applications don't have access to creating any of them. We create the pool. They go from extra small to large, and anything beyond that, they can request. And we will be able to bootstrap into this account, but again, control at that specific application or logical unit level. Not everybody get access to it. This is how actually we make sure that, it's not overused or, misused. So one of the key technology or the functional units that I touched on for our database platform as a service, our self-service layer. So self-service layer is again a REST framework that we built internally, and this is actually the central theme of our and this similar self-service actually outside of Snowflake. We do this across the board. Now the self-service layer, if you think of it, is nothing but workflows, or you call it compound statements, right? So we have pre-created workflows and compound statements that actually maps to an action. And these compound statements are created using a combination of Snowflake SQL and commands from within our multiple service layer. For instance, metadata service layer. So when you make some changes using an action, we would have to register that into our metadata layer. So when they execute this compound action, a whole thing's happen. It is not, so that's what, the access management, all that is done under the covers using the self-service layer. Our Snowflake users that I showed before, our support team, everybody, all of them have to use the Snowflake self-service layer. So the statements or the compound actions that we support are across the board. They are administrative tasks, they are application tasks, provisioning. If you think of creating databases, creating schemas, managing permissions, all that is done through the self-service layer. So we support both what we call as control and data plane actions. Data plane actions are standard actions. I already mentioned creating, granting permissions and managing, network and whatever. But control plane action is interesting. So I talked about the Snowflake redirection URL, or we call as regionless URL. So to manage regionless URL during a failover scenario, we have to do, based on which cloud service provider we use, we have to actually do DNS record management, for instance. Because you have to make all the, updates to DNS to make sure, the failover happened and the applications are now rerouted to the right place. So that's a control plane action. So this framework, if you think about it, it is not just Snowflake framework. This framework actually can do things in the cloud service provider space. It can do, stuff in, all these service layers. So, that's really powerful. The other advantage of this service layer is what we implement, something called a break glass access. So in our Morgan Stanley environment, we don't grant persistent access to any human IDs. So if they want to access their Snowflake database, for whatever reason, protection emergency, the first thing they have to do is come through our break glass access layer. It's a Snowflake self-service command saying, grant me access. So the service layer then actually goes in and provisions all the permissions that are required and only allowed what this user is entitled for. He cannot ask for more. He cannot, So let's say account admin. I cannot ask for account admin if I'm only entitled to read data. So this actually has the intelligence to do so. Now, the break glass actually has an expiration window, so beyond which the access automatically stops. This is part of one of the key audit requirements. So we don't have any orphans. We don't have any, unnecessary permissions sitting around in our accounts. So that's actually, this is our central component that we use. Another thing actually worth mentioning is, this allows us to manage granular credit reporting as part of a platform as a service, as I talked about cost transparency. So every application wants to know how much did we, really consume. So that's another function we do. So if you remember, in one of the pages I was showing that a logical level application ID, there's a unique ID that gets it. So if you look at the Snowflake, if you look at Snowflake query, that will be part of that query. So when you look at the usage or the credit usage data, we'll be able to then map that usage back to the application who would have initiated the query. Thereby, the credit consumption can be, so if you look at it, we have a very detailed reporting, actually goes to our senior management. So in that dashboard, they will be able to see which application has an ownership. That's another data we capture as part of a metadata layer. So there's a hierarchy. So they will know which department and which organization actually did use this, how much of the credit was consumed by that specific application. It was tagging, but remember, I talked about a metadata service layer, which actually sits on top of it. So whatever happens in Snowflake first gets recorded in our metadata layer. And the service from that point, after it gets synced into the metadata layer, is when it executes these statements to provision that. So we know how exactly that happens. So nothing is done outside of this framework. So this is a disaster recovery illustration, as I talked about. So this actually shows how we use logical unit for creating this high availability. So if you remember, we were talking about logical units having two different strategies. One of them is, a replication, or we call it DR. The other one is dual ETL. That application choose. Some applications say, well, we don't want to take care of the data consistency because, kind of happens with the replication cycle. There are some delays, but, well, they're still okay with that. But some applications want to have control over it, right? Because, they manage their ETL cycle. So they choose dual ETL. So this is kind of what happens. So if you think about these blue boundaries are, Snowflake accounts, right? So as I said, when these environments are created, we create this logical pairing, and we use multiple accounts from different regions, and these logical units are deployed into this paired account. So whatever happens on the primary, our high availability service that handles that high availability feature automatically bootstraps these logical units into the secondary side of the Snowflake account. Applications don't have to do anything. Our service layer takes care of that. So what happens here is that, let's say application 1 chose, replication as a strategy. So this is a typical command they would run, a Snowflake self-service command they would run. So when they run this one, that is their logical unit, and they created a primary database. So we kind of, under the covers, using our service, we mirrored that into the secondary account already. Now, and then we use replication groups and failover groups, so thereby the data sync already started happening. Applications can control the replication frequency, according to their needs, but this is now Snowflake in the works, actually start pumping data from one side to other without having to do anything. Applications over, so remember we said the client redirect URL or the regionless URL, that is being deployed. Now, once that happens, the application, so the primary URL, we do all the DNS work in our cloud service provider to make sure that the URL is now pointing to the primary side of the account. Now, that's how to be careful. So, okay. So applications wanting to, there are various types of all kind of possible applications, Python, ODBC, JDBC, you can think of it. They're all accessing through this regionless connection URL, which then routes them to the current primary side of our paired or logically paired Snowflake. So let's say if they want to failover, they will run another command. And so with that single command, remember, they're only just running one single command from our self-service layer. We do all the plumbing work by reversing all these, using the Snowflake commands, the functions of this primary and secondary. Now they have switch roles, and the replication will start, the data will start flowing the opposite way. And they can do this at will, depending on their need. They can, whenever they want to failover, with the single command action, they can failover at any time. Now let's look at, how a dual ETL application would have done it. So this is kind of different because we don't need a failover group in this scenario, because this is application managed data mirroring or dual data loading. So when the application bootstraps and they say, okay, our strategy is dual ETL, we would have done this. So we create two standalone databases. They actually say, well, create database. So what we do is we actually create another database for them in our secondary account. Okay, so the same client redirect URLs and are all still available because it's required, because dual ETL applications can also fail over. Now you see here the application client redirect URL or the regionless URL is pointing to the current primary. And as with the other one, the same thing happens here. So we'll do, the application will connect to the client direct URL, and they will be able to connect to the primary side. Now, this is a core feature. The applications may decide to do dual ETL pipeline because you know what? They control their data mirroring. So they have two parallel pipelines going to either side, processing data simultaneously. We also allow what we call this else-safe data loading. So they don't have to go independently from on-prem or, through because of latency reason. They can actually mirror from one of the primary sides straight into the secondary side if they want. That's also allowed. So let's think about the failover scenario for this application. So they can fail over. So coming back to the logical partitioning concept here, you see they actually can independently fail over and pointing to two different accounts at the same time. So this logical partitioning of the Snowflake account allows us to do this, right? But if you are not doing it, and obviously, everything fails over, all the application has to be on one side or the other. Now, we have also implemented a cool feature, and this can only be run by our service team or the support team, and they are the only one who, by the way, Snowflake self-service tool has certain type of privileges, right? So all actions cannot be run by all the users. The certain privileged actions can only be run by a support team because, they have application or production impact. So in this case, let's say there is something, happening onto one of the region and they want to fail all of these applications over, they can easily do so using what we have implemented is called a one-click failover. So with a one-click failover, all the applications, all the logical units that immediately fail over to the other region. And, so when there is a concept of a home, so we'll say primary is, let's say east. So when the problem has been resolved, they can then fail that back, thereby all the logical units are now pointing to the other side. It has come handy. Believe it or not, you would think that, cloud with multiple redundant zones and whatnot, but it has happened. So this feature came handy when it happened. Okay. So this is all actually one of my favorite topics is, disaster recovery. Now, if organizations, I believe, even though they are in a cloud, disaster recovery, I believe, from our experience, is a serious business. So from organizations like ours, we take it seriously. One of the key policy requirements is that no production applications can be deployed to environment unless there is a disaster, a DR scenario, cross region. That's a critical requirement in Morgan Stanley. Now, Snowflake has introduced this cool feature, like I already talked about it. It's called account replication. So account level replication, these are, some of the benefits of account level replication. Now, the interesting thing here is that this replication feature will allow you to fail over cross region using, a couple of the whole entire orchestration becomes very simple, right? With a couple of Snowflake commands, you will be able to fail over from one region to another. They actually also support cross CSP failover. So if you have multiple, you have Azure versus AWS, you can do so using the, their failover, account level failover feature. And in our case, we started a different journey, but now that this is, this feature is available, we are definitely using that. One of the feature in the pipeline that we are looking forward to is a granular replication support. They are now supporting at the database level. We are looking forward to their support this at the table level. The advantage of supporting this at table level is that will significantly reduce the replication latency and also the cost. Because as data moves, for instance, if you have lot of temporary data, you don't want to be replicating the entire database because you're only you only care about certain set of tables, right? So the table level replication is a nice feature they're working on. It's almost coming. The other feature that we are looking forward to is there are certain limitations at this point, right? So database is supported, shares are supported, but there are some objects that are not supported. But I think most of the important ones are in the pipeline. It's coming soon. So we are definitely looking forward to that. That actually will complete the entire replication, requirements in Morgan Stanley, because these gaps, we have to actually do our service level copying of such things, because it's not supported. So as they introduce more and more resource types in the replication, will be definitely, migrating to that. So that's kind of the end of the story. So our Snowflake journey, to be honest with you, has been a very pleasant one. Thanks to our Snowflake team here, they've been extremely supportive. And we're looking forward to doing more Snowflake and the collaboration. And we collaborate with their engineering team. We have a lot of, symbiotic relationship. We get things done. Thank you.